Today we are going to discuss about chromosomal mutation in chromosomal basis of inheritance, chapter 3 in Botany. So chromosomal mutations. So as we have know what is mutation. So mutation means sudden heritable change, and there are two types of mutation, that is gene mutation and chromosomal mutation. So gene mutation is nothing but the point mutation. We have discussed it in the previous class. And now we are going to see the other mutation called chromosomal mutation. So chromosomal means alteration in the number or structure of the chromosome is called chromosomal mutation or chromosomal aberration. So change in number of the chromosome or change in the structure of the chromosome, then it is called chromosomal mutation or chromosomal aberrations. So based on that, it is classified into two: changes in chromosome number and changes in chromosomal structure. So here we are going to see the changes in chromosomal number, which is known as ploidy. As we all know, the constant number of chromosome is present in the organism. For example, human being 46, okay, chimpanzee 48 and Drosophila 14. So like that constant number we know. So based on that, there is any change in the basic set of the chromosome, then it is known as numerical chromosomal aberration or ploidy, that is changes in the number of the chromosome leads to numerical chromosomal aberration or ploidy. So there is any change in the basic set of the chromosome in number. Okay, that is called numerical chromosomal aberration or ploidy. Two types of ploidy. So ploidy involving individual chromosome within the diploid set. So individual chromosome within the diploid set itself, the change occurs means, then it is called Aneuploidy. The entire set is changing. The ploidy changes the entire set of the chromosome, then it is called Euploidy. So only the diploid set within the diploid set changes occur. It is called Aneuploidy. The entire set of a chromosome is changed, then it is called Euploidy. So here I had given the classification of ploidy, which we going to see. So the ploidy is divided into Aneuploidy, Euploidy. Aneuploidy is again divided into hypoploidy, that is hypoploidy and hyperploidy. So hyperploidy is divided into trisomy 2n plus 1, double trisomy 2n plus 1 plus 1, tetrasomy 2n plus 2, double tetrasomy 2n plus 2 plus 2 and pentasomy 2n plus 3. So these are the types seen in the hyperploidy, that is hyperploidy. And hypoploidy monosomy 2n minus 1, double monosomy 2n minus 1 minus 1, nullisomy 2n minus 1, 2n minus 2, double nullisomy 2n minus 2 minus 2. And euploidy is divided into haploidy, that is nothing but monoploidy. So it is divided, the haploidy is divided into monoploidy, diploidy, polyploidy. So polyploidy is again divided into Autopolyploidy, Allopolyploidy. Autopolyploidy again divided into Autotriploids and Autotetraploids. So this is the classification of ploidy. This they may ask in 5 mark or 3 mark question. You have to just draw the flow chart of the classification or types of ploidy. So first we will see about the Aneuploidy or Heteroploidy, that is Heteroploidy. So the diploid number is altered either by addition or deletion of one or more chromosomes is called Aneuploidy or Heteroploidy, that is the diploid number, that is the diploid set of, in a diploid set, any one may be added, any one of the chromosome may be added or deleted in the same species, then it is called Aneuploidy or Heteroploids. Again, this aneuploidy is divided into, that is, hyperpolyploidy and hypopolyploidy. These are the two types seen in aneuploidy is that is hyperploidy and hypoploidy. So this is the types of aneuploidy you can see. First it is disomy. So only two, that is it is normal condition. Disomy is normal condition. So monosomy you can see here there is no set of, that is a single set is removed. That is a single part segment is removed from the disomy, that is monosomy 2n minus 1. Double disomy you can see the two parts, here one segment is removed and here one segment. So it is 2n minus 1 minus 1. So two sets is removed. That is double monosomy, that is monosomy. Nullisomy, in the both the sets, in the both the chromosome, you cannot see the last segment here. No, that two sets are removed. That means 2n minus 2 is equal to 0. Trisomy. So trisomy means this is double somy. In this a new one is adding to this set. That is 2n plus 1. That is trisomy. Same way in the trisomy, 2n plus 1, that condition you know. Again another one is adding. So here 1 and here 1. That means 2n plus 1 plus 1. Double trisomy occurs. Tetrasomy, you can see the 4 chromatid like structure, chromosomes are adding. So 1, 2, this is 2 plus again 2. So this 2 and this 2. So 2n plus 2 is added. Pentasomy, this 2 plus 3 is added. This is the normal. If you see this diagram itself, you will understand what is hyperploidy and hypoploidy. So this is hyperploidy diagrams and this is hypoploidy diagrams. So now I am going to explain this thing in detail. Hyperploidy. Hyper means what? High. Adding of one or more chromosome to the diploid set. So diploid set you are adding one or more chromosomes is called hyperploidy. 3 types. Trisomy, adding of single chromosome to the diploid set. So here you see no, one set is added, okay, to the diploid chromosome. That is called trisomy 2n plus 1. So example that is it was reported by Blacksey in 1910 in Datura stramonium. That this trisomy is seen in Datura stramonium, which belongs to the Solanaceae family. Double trisomy 2n plus 1 plus 1. That means 2 pairs are added to the normal diploid set. So here you can see the 2 pairs. This 2 things are added to the diploid condition. So that type is known as double trisomy. Tetrasomy. So tetrasomy means what? As I say no, this normal condition disomy and adding of 2 sets of chromosome is added to it. Then it is called trisomy 2n plus 2. And double tetrasomy means additional 2 is added to the tetrasomy. So here 2 and here also 2. So 2 plus again another 2 will be added here. So in this portion again another 2 will be added here. So that is seen in some of the varieties of wheat. 2n plus 2 plus 2. Pentasomy. So pentasomy means, so for the diploid sets, it is disomy condition, 3 chromosomes are added. So then it is called that is pentasomy. Next, hypoploidy. Loss of a segment, you can see here. So you can see this is normal condition. Loss of a segment is this segment is not seen here. So that condition, that is the loss of a segment in the diploid set of chromosome. Then it is called hypoploidy. There are 2 types. Monosomy. Monosomy means loss of single chromosome. from the diploid set. Monosomy 2n minus 1. Double monosomy 2n minus 1 minus 1. And triple monosomy 2n minus 1 minus 1 minus 1. Like that it happens. It is seen in maize. And you can see here also in the diagram also the removal of, in here two segment is removed. This in this condition the two segment is removed, that is double monosomy. Same way the entire segment is this one is also removed, means that is monotrisomy, that is triple monosomy. We can say it as like that also. Okay. Nullisomy. Nullisomy, that is a loss of a pair of homologous chromosome or two pairs of chromosome is completely deleted from the diploid set. So you can see here. So this is nullisomy condition. No, the two segments of the chromosome is deleted, that is removed in the diploid set. That condition is known as nullisomy. 2n minus 2 is equal to 0. And double nullisomy 2n minus 2 minus 2. So first one segment is removed. Again another segment is removed from the diploid set of chromosomes. So that is called nullisomy. Euploidy. So euploidy, where the organism possesses one or more basic sets of chromosomes. So the organism has one or more basic sets of chromosomes added to the diploid condition. Okay. So there are three types: monoploidy, diploidy, polyploidy. Monoploidy means haploid condition, single n. Diploid means 2n, that is seen in the gamete condition. And polyploidy we are going to see in detail. So polyploidy. So more than 3 chromosomes are added to the two basic set of chromosomes, then it is known as polyploidy. 3 or 4 or 5 or 6 basic sets of chromosomes are added, then it is called, that is in a diploid set the 3 chromosomes are added, then it is called triploidy, 3x. 4 is added, tetraploidy, 4x. 5 is added, pentaploidy. 6 is added, hexaploidy. So the ploidy is also 2 types, as we discussed in the classification of ploidy: Autopolyploidy and Allopolyploidy. Autopolyploidy, 2 haploid set of chromosomes derived within the same species. So in the same species 2 haploid sets are derived. So there are 2 types: Autotriploids, Autotetraploids. Autotriploids. So 3 set, triploid itself 3. So 3 set of genome is added to its own genome. So 3 set of chromosomes are added to its own genome. And it produces artificial crossing over between autotetraploid and diploid species. Artificial crossing over takes place here. So due to this, defective gamete formation occurs. So because of this, abnormal characters will be exposed. Example: banana usually triploids, and triploid sugar beets, high sugar content they produced in the diploid condition, and resistant to molds, that is fungal infection. It will not attacked by fungus. Okay, fungus. And common dew gas, cyanodactylion, that is it is an autotriploid. They may ask in 1 mark, even in your NEET exam also they can ask. So seedless watermelon, apple, sugar beet, tomato, banana are man-made autotriploids. Okay, keep it in mind, they may ask in 1 mark. Autotetraploids, 4 copies of chromosomes are added to its own genome. That means doubling of the diploid species. If the species is 2n, 2 into 2, 4, the doubling occurs. So the examples are rye, grapes, alfalfa, groundnut, potato and coffee. These are Autotetraploids. Allopolyploidy. Two or more basic set of chromosome is added, and it is done only between the two closely related species. So it is taking place, that is allopolyploidy takes place between the closely related species only. So examples here in Raphanobrassica, G.D. Karpenchko in 1927, a Russian a Russian genetist crossed the radish, that is Raphanus sativa, 2n is equal to 18, and cabbage Brassica oleracea, 2n is equal to 18 is crossed, and it produced in F1 it is sterile, and after doubling in F1 he got it fertile. And his acceptation, in the acceptation, what means in root it should be radish and in leaves it should be cabbage, but it occurs vice versa. So it would make the entire plant edible, but it becomes vice versa, and he got disappointed. So I will explain here. Raphanus, that is Raphanus sativa, radish, is crossed with Brassica oleracea, that is cabbage plant. So they took the diploid condition is 18, normal 18, while gamete production, that is from Raphanus, n is equal to haploid condition, n is equal to 9, and here the stand, that is n is equal to 9, added 18 condition, and you get a sterile hybrid. So what he done means, he done doubling, that is 2n into 2, that is 4x, doubling he got it 36. So according to him, in roots he must get radish, in leaf he must get cabbage, but it occurs vice versa. In the root side he got it cabbage, and in the leaf side he got it radish. So and it is not edible also. He think of that he will get on roots radish and in leaves cabbage, means it is edible, but he got disappointed because it occurs vice versa and it is not edible also. Okay. And same way the next breeding also takes place. This is the famous one, that is triticale, that is the first man-made species. So in a wheat variety Triticum durum and a rice variety Cecale cereal, that their chromosome number is 2n is equal to 28 and 2n is equal to 14, and this is in tetraploid condition. Triticum durum is a tetraploid condition, that is 2n is equal to 4x is equal to 28, tetraploid. From that gamete formation 2n, that is n is equal to 2x is equal to 14, and here n is equal to 7. So after combining you are getting a triploid condition, 2n is equal to 3x is equal to 21, and it is a sterile. Now the doubling takes place by colchicine. So inducing colchicine is used to induce the polyploidy condition. So colchicine is induced, and after that 2n is equal to 6x is equal to 42. This is an hexaploid condition. This is a triticale, and it is the first man-made cereal appeared. And there are some of the things you must know. Colchicine, it is an alkaloid. It is alkaloid. It is extracted, means taking from the plant root and corms of Colchicum autumnale. So at low concentration on the growing tips, at the tip of the plant, you are getting this colchicine. It initiates polyploidy in many plants and does not affect the source plant, because it does not affect, it initiate another plant, it is initiating, but for its own it is not producing any harm to the producing plant, that is Colchicum autumnale, colchicine. So presence of this anti-colchicine in the plant Colchicum. Because of this, the plant doesn't have any mutation or polyploidy effect in the plant, but this colchicine can affect another plant or animals to induce mutation or polyploidy. Next we move on to the significance of polyploidy. So it is an important 5-mark question. So first one, more vigorous and more diploids can be produced. So vigorous diploid plants can be produced, and ornamental plants also produced through long flowers, that is long flowering duration, larger flowers than the diploid. So it is due to Autotetraploids. They are giving colorful, attractive, large flowers which is used for bouquets and decorative items during the functions. Okay, for that it is using. And Autopolyploids have high fresh weight and water content. So if the water content and fresh weight, if you are that is plucking the Autopolyploid vegetables, it gives high weight and watery content, and it gives the profit to the farmer. Aneuploidy. Aneuploidy means the phenotypic effects of loss or gain of different chromosomes can be easily find out. So the loss or gain of chromosome by physical appearance you can see it. Many angiosperms are allopolyploids. So most of the angiosperms are allopolyploids, and it is a raw material for evolution. So it plays an important role in evolution of plants. Thank you for watching the video. If you have any doubts, post your doubts in the comment box. If you like the video, give a thumbs up, share and subscribe to Science Easy Tech channel.